to progress in transportation has always been the proper use of available power. Primitive man noticed the power of water currents and learned to use them to float vast distances on rafts. But better sources of power were available. As soon as man learned to use wind, the sailing ship took over. Then man learned to use steam, and the steamship replaced the sailing ship. Well, the rule was that the faster transportation method replaced the slower as the new method developed sufficient economy and reliability. This rule applied on land as on sea, and so simple horsepower gave way to horsepower in steam engines. Then in gasoline engines. And man looked up and discovered that the rule applied in the air, too. Commercial progress in the air has always resulted from the proper use of new power sources, but only when they met basic power, reliability, and economy requirements. The first aircraft engine to show promise for commercial air transportation appeared in 1925. It was a good engine, but its fuel consumption was too great, its power too low. 2 years later, this engine powered a bold young man and his heavily loaded airplane all the way across the Atlantic. Although this achievement was hailed by the world, the air-cooled piston engine did not improve enough to warrant commercial transport use until 1933. Then aircraft engineers of the company, which is now by far the largest producer of commercial aircraft in the world, decided that the factors of power, reliability, and economy were right. The DC series was born to mark the true beginning of air transportation as a mass travel medium. The famous DC-8 made the best use of the source of power available in its time. Using the same source of power as competitive aircraft, it proved its superiority in speed, load-carrying ability, economy, reliability, and ease of maintenance. But the demand was for more speed, longer range, and even greater dependability. So the makers of the DC-8 took the next step in air transportation progress, the development of the four-engine transport. The DC-4 first flew in 1942. Military versions of this aircraft were the mainstays of our transport operation during the shooting war and the Cold War that followed. And experience gained in four-engine transport design, manufacture, and operation led to the introduction in 1946 of the DC-6, America's first new post-war commercial transport. Pressurized and air-conditioned, it set new standards for speed, passenger comfort, and luxury, while being even more economical and easier to maintain than its predecessors. At this time, a newcomer, the jet engine, appeared. Even in 1946, its power-to-weight relationship compared very favorably with that of piston engines. But its fuel consumption was far too great, and a mere 50-hour period of operation between overhauls made it impractical for commercial use. The military found the jet engine provided the answer to their tactical requirements. The D-558 Skystreak and the famed Skyrocket provided important design information. The B-43 was America's first jet bombing plane. The manufacturer of these airplanes studied jet development carefully. At this time, it found no engine with the potential for practical airliner application, but it continued to produce highly efficient military jets, like the all-weather fighter, the F-3D. The company also continued its tradition of providing the airliners which gained the greatest public acceptance by using new piston engine developments in the DC-6B, which cruises at 315 miles per hour and has a top speed of 372 miles per hour. But exciting things were happening in the jet engine field. At last, jet fuel consumption in relation to power began to show a marked improvement. An engine type appeared with almost unlimited power potential and reasonable weight. Its fuel consumption was still too high, its power too low, and its overhaul period, a mere 300 hours, too short for consideration. But commercial designers studied it intensively. They had ample opportunity, as this engine was used in the F-4D, the first carrier-based airplane to hold the world speed record. Its engine's performance was studied under all conditions, with particular attention given to reliability and ease of maintenance. The same engine type was studied further in the A-3D, largest and fastest attack airplane to operate from the deck of a carrier. Piston engines made a further advance as the turbo compound engine was perfected to the efficiency needed for transport operations. The best commercial use of this source of power was the DC-7. Cruises at 360 miles per hour and has a top speed of 406 miles per hour, and established the first high-speed non-stop transcontinental service. A later version, the DC-7C, is capable of spanning the oceans non-stop. Post-war DC-6 and DC-7 transport airplanes fly the equivalent of 40 times around the world every 24-hour day. And their manufacturer continues to expand in jet experience with the supersonic research airplane, the X-3. With the world's smallest, fastest, lightest bomber, the A-4D. With the speedy tactical bomber for the Air Force, the B-66. Completely integrated plans were prepared for the moment when jet engine development warranted the use of this source of power in a transport airliner. The moment has now arrived. Jet engine fuel consumption in relation to power almost equals the latest and best piston-type engines. And jets show great immediate power superiority. Overhaul time approaches that of the piston engine, a factor which favors the jet because of its greater speed and the greater distance traveled between overhauls. And the engine reliability picture at last becomes what is required for airline operation. Commercial requirements are met in power, reliability, and economy. And the prospect is that all three will be greatly improved as the engine is further developed. At last, the plans that have been so carefully prepared can be used. Into these plans have gone all the experience gained in the development and operation of the DC-3, DC-4, DC-6, DC-6B, DC-7, and 7C transport airplanes, each of which was first in public and airline preference in its era, plus all the experience gained in the development and operation of the jet Skystreak, Skyrocket, B-43, F-3D, F-4D, X-3, A-3D, A-4D, and B-66, the most varied jet experience in the aircraft industry. This unequal experience is welded together in the world's speediest, most practical, reliable, and economical jet airliner, the DC-8. The DC-8's speed, range, and payload give this new airplane approximately 2.5 times the productivity factor of the best present-day airliners. It will travel from Los Angeles to New York in less than 4.5 hours. From London to New York in 7 hours. From Tokyo to Seattle in 9 hours. From Stockholm to Rome in 2.5 hours. From Miami to New York in 2.25 hours. The key to man's progress in the field of transportation is his proper use of new sources of power as they become available. So, the raft was replaced by the sailboat by the steamboat, the horse by the steam and gasoline engines, the water-cooled engine by the air-cooled engine. And now the greatest advance of all, in the biggest step forward in transportation history, the development of the intercontinental jet airliner, the DC-8. By 1959, the DC-8 will be in operation and available to start service on world routes. Its passengers will travel in unprecedented luxury, cruising 7 miles high, far above the turbulence caused by weather and terrain. It will provide smooth, quiet, vibrationless travel at nearly 600 miles per hour. It will maintain its manufacturer's record of always providing the airliner that is most economical to operate and easiest to maintain and service. On short trips and long, it will allow the airlines to reduce travel costs even further while greatly improving the quality of service. The DC-8, the latest and best use of a new source of power, the finest airliner the world has ever seen.